The idea is that now these days they have a data, and then almost 99% of the people are interested in bigger size of data. On the other hand, my interest is actually other way around, which means if you have a certain amount of data, then you're going to have two choices to get the better models. Number one, you're going to have more data and then make your data larger, or other way around. You kind of optimizing the data and then have a small amount of data, but that is big enough or good enough to do the performance or to design the machine learning system. So that's the idea of it. So I've been studying those ideas for the quite a long time. Yeah, only 3 years ago. So then this is one of the recent one I try to explain to you. So before I start, most of you have no idea who am I. So my name is Song-gyu in Korea, but most of my foreign colleagues call me Amang. And then you also call me Amang or the Kim or Dr. Kim, Dr. Amang, whatever you like to do. I used to be in the industry quite a long time back, starting year 2002 to the year 2012. I used to work in the small, tiny company called Samsung for the 10 years. And then later, I moved back to the academe, which is the various universities all around the world. Here's an example. Okay. So why I said it's all around the world, because first job in my academy in the Philippines, I have some colleagues over there who used to study over there but not overlapping with mine. And then move on to the UAE. So I used to, of course, I born in Korea, raised up to the undergraduate for more than 10 years. And then in the US, I did study in the US for my master and my PhD program. And then going back to the Philippines around the 4 years. And then went to the UAE around the 6th year. And then going back to the Asia again, which is Macau at this moment. Now it's been 3 plus something years. On the other hand, my undergraduate degree is in physics, okay? And my master degree in the computer engineering, electrical and computer engineering, plus I was working at the IT company 10 years. And then my PhD program in the just research under applied mathematics. So because of that reason, I have a diverse of the research area, not just for the research area, but also the diverse of the different domain of the study. As you may know, there have a different viewpoint between scientists and engineers, and then engineers and the business. Although they dealing with the same thing, the operations, for example, they dealing with the operation as the same name, but in the viewpoint of the scientist or mathematician, it's not same as the engineers who dealing as a system engineering. Also, that viewpoint is totally different than somebody who dealing with the operations management as a business. Although they say same thing, they say the operations, but they have a different viewpoint. There another example, for example, for the IT. Okay, IT is mainly computer, right? Computer scientist viewpoint different than computer engineering viewpoint is different than the MIS. Now the business guys call the MIS, Management Information System. They dealing with the same thing as a computer, but they dealing with a different thing. For my strengths, I have all 3 different views. I know what business guys talk about, I know what engineers talk about, I know what science guys talk about. So that is one of my benefits. And then same manner, as you can see, I have a variety of experience in the different world. And then that one actually the quite interesting experience. Let me give you an example. in the Philippines. There's one colleague I met at the Philippines. One of example in the Philippines, or one of good or bad things in the Philippines, they celebrate the Christmas almost the end of September. They start to building up the Christmas tree, and then they do the promotion for the sales until the February. Right? In the other hand, UAE, there's no Christmas. Yeah, even in the Christmas, if it's the weekday, you should go to the work. Okay, so for my experience, it's a quite culture shock because when I was in the Philippines, I celebrated it's quite surprise, right? In the end of September, you can see the Christmas tree in the big shopping mall over there. But when I go to the UAE, it's actually the middle season, around middle of December, nothing. Okay, so it's quite shocking, and then it's actually also related with the behavior of students, also quite different.
Yeah.
Philippines, and then the school when I was teaching for the AIM, is quite diverse with many Indian students also. So I know the behavior of, I'm not saying it's bad, okay, but the different, right? Different behavior for the Indian students, and then that is a totally different behavior in the UAE students, and then that is also totally different than the Korean students. In case of Korean, I didn't teach for the students, but I used to teach for the internal employee. When I was working at Samsung, I'm also working as a internal lecturer for the teaching like a Six Sigma, TWIS, theory of inventive problem solving, that kind of thing I also teach when I was in Samsung. So I know the different behavior. And then one of the example for the UAE, Filipinos, they like social media. Okay? And then I use social media for the conducting the student. It's quite common. When I go to the UAE, I try, department chair call me there, don't do that. Number one, they are not interested in. I mean, they are interested, but not officially they are interested in. Because they cannot commit or they cannot say it's enjoy for the social media, particularly ladies. Okay? If you take a picture for the ladies for the social media without permission, yeah, you're gonna have a serious problem in the UAE. Believe me, yeah, it's gonna be really serious, right? And then for the UAE, in other words, now it has been changed, but at the beginning when I went to the UAE, they are separating the classroom, girls, boys. Even in the building, before I came, the building is separate. Girls building, boys building. And then when I about to go there, then they are merged into the building, but still, when you gathering the students, they separate. The boys are still over there, girls are still over there. Not like Finland, it's totally different. Okay, so those kind of different viewpoint becomes to my strengths. Why I'm saying this, why this is related with my topic? Because my research topic, if you have a chance to take a look at the Google Scholar or the LinkedIn, my research area is quite diverse. Okay? Recently, I'm dealing with the performance measure of machine learning algorithm. That's one thing. But just before the published one paper is about the biometric authentication system by using the machine learning algorithm. Before, I published one Korean book, which is about the data science. Before, like around year 2019, I developed the one network architecture design by using the blockchain, which is called the blockchain governance scheme. If you are interested in the network architecture for the improving the security, those ideas you might be interested. Okay, and then before what I did, before you do the authentication, I'm interested into using the ECG, the heartbeat. So one of the major ideas for the ECG I use, usually the ECG is used for the detecting the heart disease. It's more related with the health science or the biometric medical. But for my usage is actually starting with one of my colleagues initially when I was in the UAE. Actually, one of the presenters who used to teach the lady is actually the same university. I used to work at the California University also a couple of years, not as a professor, but as working as a researcher. But anyway, during that time, I do the research making an authentication. So identify like your fingerprint, okay? Instead of using the fingerprint, using the heartbeat. That's actually another series of research. And then between them, I'm also interested in the game theory. So it's called stochastic dual game. So dual game is more like the competing with each other. But anyway, so the long story short, I'm designing the mathematical models. If you want to get into the business, when will be the best moment? Even though there is no other people out there. So it's called the blue ocean, red ocean. If you are involved in the business, you may have heard about the blue ocean strategy and red ocean strategy, right? But in the blue ocean strategy, people usually say, hey, you're jumping into the first as soon as possible. But in my models, saying that it's not. Even though there is a blue ocean market, you should wait until a certain amount of time. What I did, I actually developed the mathematical models as a mathematical proof. So I prove it. You cannot get into the new market at once. No, you should not. You should wait a certain amount of time. Actually, the one of my calculation, you can calculate when will be. Okay, so that kind of things I do it because of the. What happened?
Just move the mouse, that's it.
Oh, okay. Alright, so and then I used to be the associate professor in the business. So and then the first job in UAE, also in the business department, and then now I'm working at the computer science department. So now because more going back to the science and engineering and so on. Okay. So today's agenda. Today we're going to talk about the compact data learning first, and then I kind of designed, I think it's actually already available, but I kind of designed the statistical forecasting reference function, which is a really simple formula, but interestingly, you can actually, when you use this function, I mean, it's not formally invested, but roughly speaking, when you calculate the MSE or MAE for the performance measure for the regression, this function beat every machine learning algorithm at this moment. Yeah, whether you believe or not. Also, I don't believe neither yet, because I tried several machine learning algorithms with the same time series system. This function beat everything. In terms of MAE or MSE, the error portion. This is always give the minimum. Yeah, I'm not saying this is a conclude, because it's still under investment. But at current status, yeah, this is how it works. But anyway, so this is the one thing. And then the other one, I'm developing, I give you how these models and the compact data learning is going to be working on a certain stages. It's called the NML training system. If you are involved in the computer networks or the internet, you know what is the NML training system. So that will be the cases and then the overall summary. It's quite simple, right? So first thing, so what is a compact data learning? This is my idea. It's not exactly my idea, but I bring up those terms as a compact data learning. Meaning that when you do the training of the machine learning, many people think about, and most of the people think about, you should have a lot of data to get the good model, right? As I said, from my perspective, actually it's not always the case. It would be better to have good data. Small amount of good data is always better than large amount of sloppy data. That's what I believe, and then this is one of ideas for that. And then it's starting with the discrete cases, or starting with the classification problem first. So that is another research before this one. So the accuracy, precision, recalls, F1 score, that kind of a performance metrics. Even though I reduced amount of the data, still the performance is almost equal. Might be slightly lower, but statistically it's okay, right? So you can actually measure how much you can reduce the data set. That's the idea about the compact data learning. So this is a discrete cases. So they have a two-way of CDL. So number one, if this is the original data. Okay. So if you reduce frequencies, features, even though you just have less than 20% of data, okay, the accuracy is almost the same. Slightly lower, but again, statistically it's equivalent. And then, of course, you do the both. So in case of samples, you have 82%. So reducing like 18%, right? 18% reduced. Both of them, you reduce them, then that amount is almost slightly, smaller than this. So that is a way to reducing the data. So what I did, once I reduced them, and then we do some sort of a statistical test, like a G-test, T-test, and so forth, hypothesis testing, and then it comes out, although they have a certain level to reduce the number of features, which give you the same accuracies or similar accuracies. They have the idea of a CDL, what will be, what those number is going to be. That's the idea of the CDL. Some of the research you do before asking about for optimizing the number of layers, optimizing the parameters, and so forth. The main point is that if you run the training, then that optimization have less value. Why? Because you already did that. Right? The major point of CDL is before the training. Before you put the numbers, data into the training session, you can figure it out. What will be the optimal number of a sample? What will be the optimal number of a feature? And then optimal number of features not only for the number, but also which features is more important and which features is less important. Before, the point is before training. Before training, that's the idea. They have a similar research already available, so I try to compare with my ideas to the others. That is because it's not the part of this research, it's the previous one. So if you are interested in, let me know. I will send that one also. Okay. So that's the idea about the CDL. So for this research, it's CDL for the time series. So before. The CDL is about discrete data. It's not about the prediction. It's about the classification problem. You can use a CDL for the previous version. This one is about the time series. So if you are involved in the prediction of timing, these models might be helpful. Okay. So similar concept. What you're gonna do? You want to reduce number of data set for the prediction, but you still have a similar level of MSE or similar level of MAE, the error is going to be the still minimum. So that's the conceptual idea. Okay. So for how this is happening, because in case of time series, many machine learning professionals doesn't recognize that time series is not discrete. All right. Time series is supposed to be continuous value, which is not possibly implemented onto the computer, because in the computer you cannot implement, the 100% implement to the continuous time frame. So what we are doing, we actually do the sampling, right? So you actually pick the time to time, you select the samples. So you have pick more frequently, then you're gonna have more data with the same time. You pick less, then you're gonna have smaller amount of that. But interesting part is that, intuitively speaking, if you pick a lot of data, it may give you the better prediction, right? But actually, it's not true. It's not true. Because they have not, sometimes that's true, you choose more, then you're going to have more good prediction. But some data set, it has a data dependency, by the way. The some data set, you take the randomly select, that gives you the more smaller MSE. Okay, that's the idea. That's the idea about the CDR for the field. So, main purpose is that what will be the optimal sampling time? That's the idea, is a starting idea about the CDR. Okay? So, you have a continuous values and then you take the sampling and then your time is going to be some phases and then you have the integer number and then you have a duration. So this, and then you're gonna have two things. Number one, this one is the initial starting point because once you take the sampling, then you have some residue line left. Okay. For example, if you wanna take the sampling within the 10 seconds, but you take it every 3 seconds, you sample them, then you're gonna have 1 second left, right? So it's kind of shifting them, starting the sampling for the first 1 second, 4 second, 7 second, 10 second. So the 1 second becomes the residue for the T0. Right? So how you calculate how many samples you're going to take it, and then this one is the duration between the samples. And then between the sample duration, you can calculate this. So this is a mathematical proof. I'm not going to get through the whole proof for this, but that's actually what I did before. And then, so having said that, what you're going to do, you try to map into some sort of a prediction model, not using the machine learning algorithm, by the way. It's a more statistical way that it's quite simple. You just take the last two sampling moment. And then based on the slope, you predict what will be the next. Okay? So it's not even my idea. I mean, it's quite common to statistical regression. They do the similar idea. Okay? So to take the slope, and then for the next round, you just the slope that amount you jump it. So it's not even machine learning. But you know what is the funny thing? If you predict this way, that is always give the minimal MSE. As of now, I mean, it's not fully proof yet, but based on my experiences, this kind of a simple algorithm is way better than the other machine learning algorithm. Quite surprised. I know I'm trying to find the reason why. I mean, that's one of my future research, why this is happening, but actually it's really happening. Okay? One of the assumptions that I know is that because this is always taking the latest past, right? So it's always impact on the input or the feedback for just before what things are happening. It's like running as a reinforcement learning. Kind of, not exactly the same, kind of working that way. So that's the reason why it will give you the better solution. But this one, when you take in the consumption power or the training time, it's almost a zero. Yeah, if you're running CNN, like 10 layers, even though that's a small number, it takes at least a couple of seconds or at least like a couple of minutes sometimes it will take. You may consider, that is not a big number. Yeah, at this moment, that's true. But what if you consider as a bigger size of data? That will be increasing, exponentially increasing the training time. So, but anyway, so I do have this prediction model, and then I do have original function. Okay, so that's why I'm doing this because. So the main formula is that when you take a look at the MSE, what we're gonna do? We do have different sampling time, okay, and then calculating the MSE, right? It's quite robust. I mean, you need to do a couple of times, unfortunately. I'm trying to find an analytical way, but it's almost impossible because the sampling data no longer the analytical functions. Okay? But point is that you point to point, you find the MSE or the error rate, and then algorithmically you find the minimum, which the size of the sampling time giving the minimum MSE. So implement those algorithms, I use queuing system as a continuous time. Okay. So continuous time queuing system means that number of queues, how many customer in the number of queue, or how many number in the queue for the certain time frame, and then this is a formula for the average waiting time, and then this approximation by using the Taylor series. Okay, so then what happened is that, what it means that this function is a continuous function. Okay, this function, according to the T, is going to be the continuous function. And then you select the time to time like this, meaning that you have a sampling duration, sigma, starting with the 0.1, 0.2, 0.4, 0.6. So you actually, at the beginning, you have every 0.2 second, you select the sample, and then every 0.3 second, you select the sample, on and on, okay? So if you, and then you actually, the dot for the MSE, beautifully, they have optimal value. So meaning that if you take the sampling time around the 0.87 for this particular case, okay? I'm not saying it's going to be the general for the other. No, you should do it, the same calculation again of your data, for sure. But for these particular cases, this sampling time, MSE, so MSE is a minimum, meaning the MAE, other error performance measure is going to be the minimum. Okay? So it's working like this. Right? It's not always like, you chop, because intuitively, you should have a minimum in here, right? Because you have smallest the sampling, chop giving you the minimum, but actually it's not. For these cases, this is the minimum. Okay, that's the idea. I tried to the other data already. It's not in here, but it's not always the case, unfortunately. So I tried 4 or 5 cases. But 2 of them have a minimal in the middle, but the rest of them actually the shorter sampling give you the better solution. So I'm not saying it's like bullet, silver bullet. No, it's not. It still needs to be improved in a certain way. But the main point is that certain data set you may not need to observe your data as many as you can. You don't need to do it. Okay, that's the idea about the CRTs. So overall summary, compact data learning for time series, improve the machine learning training for the time series system. And then the lower framework accelerated for the training phases without increasing the forecasting errors, and then provide a unique strategy for the creating the compact data in the broader time series. So this idea, you can actually try to pretty much every time series problem if you have. You can try, at least you can try. I mean, again, it doesn't guarantee they give you the optimal. No, it's not, it's not, sometimes it's not happening. But at least you can try to do it that way. And then this framework says that it also provides application across the various types of time series data, including the stock market, oil, gas, and other economic time series for the designing the machine learning based forecasting system. Okay. Yeah, that's pretty much it. Okay, good. Yeah, so that's it for my presentation. Any questions? Are you interested? If you are interested, I forgot to put my QR code over there, but I bring some of my business card. It's a first and first serve. So if you are interested, just step by me and I'll give you my the business card, so you can contact me anytime. That's pretty much it. Any other questions?
You have similar field with cool.
Okay. All right. Thank you very much, and enjoy the rest of
Yeah,
your
you
conference.
have
Thank you.
similar field.
Yeah, similar.
Yeah.
Yeah, time series only.
Time series.
Also. That's why I was so curious to listen and know some points.
Yes, yes.